Section 2.6, we're going to continue with function work and graphing. And one of the first things we're going to look at is domain. So actually, I think I've been using blue for domain. And domain are the possible x values you can have. Possible x values. So for most problems, the domain is going to be all real numbers, which we outline with minus infinity to positive infinity. So in interval notation, we'll get all negative numbers, 0, and then all positive numbers. We have a couple cases where there's issues. So restrictions. We can't divide by 0, and we proved that in a few different classes why that doesn't work. So if ever we get a denominator equal to 0, we're going to restrict x. So we're going to say x cannot equal 0 in this case when it's the denominator, if x would cause the denominator to go to 0. So to find it, to find those x's, we're going to set the denominator equal to 0 and solve for x. So this is one possible restriction. The only other one we're going to study in this class is if we get the square root of a negative number. So square roots, if it's even powers, so if it's an even root, like square root is, we can't have negative numbers in there. So to find, we're going to say x cannot equal whatever those negative numbers are. And it could be a whole set of them. And to solve that, we're going to set whatever is inside. So we're going to set the inside of this. We're going to take the inside and set it equal to 0 and solve for x. Actually, we're going to make sure the inside is bigger than or equal to 0. So it's actually an inequality. So it's not equal sign. We're going to make it, this inside has to be bigger or equal to 0. So you can have the square root of 0. That's fine. It's 0. So we can have this equal bar there. But one of the things I'll kind of ask when we look at each problem is, do you see division? Do you see a square root? If not, then the answer is here. So if I don't see division or a square root, my answer is all real numbers. So if I look at 1 right away, I can say there's no division, and there's no square root. So the answer is all real numbers. Now this one is actually a pretty simple function. If you distribute the 7, you get the function is 7x plus 91. And this is a straight line. So this is a straight line that starts 91 up. So 91 on the y-axis is a dot. And it has a slope of 7. So it goes up by 7 over 1. And it will go off to positive infinity, and it will go to the left to negative infinity. So you have straight line is a simple function, and we can see that all x values are going to work. Now 2 is where we're going to see a problem. So we have division. So we have a numerator over a denominator, and we have to make sure that we don't want this, the numerator over 0, because that's a problem. So to find that, we're going to set the denominator equal to 0. So the denominator is x minus 7, and add 7 to both sides. If x is positive 7, you'll get the denominator of 0. So what we're going to say is, okay, we don't want x to ever be 7, so we write it like this. It should never equal 7. So this is the not equal to sign. But in interval notation, it's a little trickier to write. To write that we want all real numbers except for 7, we would say, okay, you can start at minus infinity, but then you're going to go to 7 and not include it with the parentheses. But then I'm going to union that with everything bigger than 7. So start at 7 and then go to positive infinity. So in essence, on the number line, this would capture, let me see if color can help. Let me do this one in blue. So in blue, we have everything up until 7, but we're going to exclude it. And then let me do this one in red. This section will be, okay, jump from 7 to everything this way. And that would be the sections that will work. So any number is going to work except for that 7. So we have this kind of interval notation where we take these two chunks of the number line and put them together. Okay, number 3, very similar. We've got a numerator and a denominator. We don't want the numerator over 0. So we're going to set the denominator equal to 0 and solve. So we'll take x squared minus 7x minus 60 and set it equal to 0. Now this is a quadratic equation that we're going to use the AC method. The AC method says take the number in front of x squared times the, let's just review this quick. So I have an ax squared plus bx plus c. AC method says take a times c. Well, our a is 1 and our c is minus 60, so we have 1 times minus 60, which gives us minus 60. And what we do is we look at the factors of that add up to b. So we want the factors of minus 60 that add to our b term, which in this case is negative 7. So we can start with minus 1 and 60. Let me just write all the factors here. Minus 2 and 30. Minus 3 and 20. Minus 4 and 15. Minus 5 and 12. Minus 6 and 10. Let's just stop there and see what that gets us. So notice all of those multiply to be minus 60. Now we look at what they add to be. So this would be 59. This would be 28. This would be 17. This would be 11. We're looking for minus 7, so we're getting a little closer. This would be 7. So we're close. We're just off by a minus sign. So if I just swap this minus on the 5 and put it on the 12, and we use the factors to be positive 5 times negative 12, notice those still multiply to be minus 60, but they add to be minus 7. Okay, so we're going to have our two factors be 5 and negative 12. So we can write that as x plus 5, x minus 12. So this green stuff will factor into this blue stuff. Now this is equal to 0 at 2 points. When x plus 5 equals 0, or x equals negative 5, or when x minus 12 equals 0, or add 12 to both sides when x equals positive 12. So what causes these bubbles to go to 0 are the opposite of these numbers. So 5, minus 12, positive 12. So in interval notation, this is a bit interesting. We always start at minus infinity, and then we're going to go until we get to minus 5. So we don't want to include that. But then we're going to pick up from minus 5 and go all the way up to 12. And then we're going to pick up from 12 and go to infinity. So there's actually 3 segments of the number line because we're trying to exclude 2 numbers. Okay, for 4, hopefully it's pretty simple to see that you just have to set this equal to 0 and solve, and set this one. So neither of these fractions can they be divided by 0. So just set x plus 7 equal to 0, and set x minus 4 equal to 0, and solve. X should not equal minus 7, and x should not equal positive 4. So those are our 2 restricted numbers. These are going to be restricted. We don't want to let x equal that. So in interval notation, we'll start at minus infinity, go until we hit this negative number of minus 7, union that with minus 7 to take us to 4, union that, start at 4, go to positive infinity. So notice we're still starting at minus infinity and ending at positive infinity, but we've got to record these 2 restricted numbers in this fashion. Okay, 5 is a bit of a change of pace. In this we have two functions, f and g, and then they want us to form what are called composite functions. And a composite function is when I take a function like g and I put it inside of f, or we take a function like f and put it inside of g. And x is the center of everything, so we put x into g, get an equation, and then take that equation and put it into f. G of x, it's f of x plugged into g, f of x plugged into g, g of x plugged into f. Other things we can do. So this one says take f of x and add it to g of x. So this just wants us to add the two functions. So add f and g. F and g. Well, f of x is x minus 3. That's f of x. G of x is 5x squared, so we just add those together. Now these x's are all different powers, and numbers can't be combined with x. So the only thing to do is to write it in order. This would be 5x squared plus x minus 3. Now the domain of this is, notice, there's no division. So in this is considered a polynomial. There's no division, and there's no square root. If we don't have those two, then the answer is just all real numbers. So we're going to say, let's see here, I think I might have picked the wrong one. Interval notation, we want minus infinity to infinity. So it's actually b. Okay. In the second one, they want us to subtract the two functions. So this is f minus g, we just have to subtract the two. And the order is important, so it's f minus g, so f was x minus 3, g is 5x squared, and we're subtracting it. And it doesn't change much, we just have a minus sign in front of the x squared now, and it's still plus x, and it's still minus 3. And same thing, so since there's no division and no square root, the answer is going to be all real numbers. Okay. Now the next part, so that's addition and subtraction. The next part gets a little more interesting. We have multiplication and division. So f was x minus 3, and g was 5x squared. And they want us to multiply. So we're doing multiplication here. And so we just have to do a little bit of bookkeeping. We're going to take 5 into the x, and we're going to take it into the 3. So we're going to get 5x to the third now, and 15x squared. So this is like 5 times 1, and we get 5, and then x squared times x is x3. Minus 3 times 5 is minus 15, and we pick up an x squared. So the answer here is 5x cubed minus 15x squared. Again, there's no division, no square roots. So in interval notation, we can take all real numbers. Okay, the last one, for the last part for this problem is f over g. F is x minus 3, g is 5x squared. And so that one's pretty simple. There's no simplifying to be done here. Sometimes students want to say, oh, I can cancel this x with one of those x's. You cannot do that. You can only cancel an x if there's an x in all three terms. So that 3 would need an x on it to cancel anything. So nothing cancels, it looks like that. But we are going to have to restrict something here because now the denominator will be, we do have a fraction. So we do have some numerator over some denominator, and we don't want that to become 0. So we're going to set the denominator equal to 0. So we set 5x squared equal to 0. Divide both sides by 5. Any number divided into 0 is 0. So you can go that way. 0 on top is fine, it just produces 0. And then we'd have to take a square root of both sides and add our plus or minus. But the square root of 0 is 0, and there is no such thing as a negative 0, so it's just 0. Now that's the restricted number. That's what the number we don't want. So we don't want x to equal 0. So we're going to say in interval notation again is we start at minus infinity, we go to 0, and then we union that with pick up at 0 and go to positive infinity. So you can kind of see the restricted value forms these pivot points in our interval notation. So we have 0 at the end of this one and at the beginning of this one. Should be enough, I think, for this problem. Okay, 6 is the same type of problem. First we add the 2, then we subtract the 2, then we multiply, and then we divide. But this one has a square root, so notice right away when I see that square root of x, we have to make sure that that's positive. You can't have a negative number in there. I mean, you can, but for all intents and purposes, we don't want imaginary numbers, so we're going to restrict that from being negative. Okay, so to add these two functions, it would just be the square root of x plus this x here minus this 15. So we can just literally string those three terms together, and that's going to be the answer for the first part. Now, the domain in interval notation. What I said with square roots is whatever you have inside of here, you have to make sure that that is bigger than or equal to 0. So all I have to do is take what's inside the square root, the x, and make it bigger than or equal to 0. Now sometimes you'll have to do algebra, like if there's more stuff written under the square root. But for this, it's just x, so the answer is right there. X has to be bigger than or equal to 0. In interval notation, that looks like this. We can let it be 0, but then it's going to go to infinity. So we can let it be 0, so we use this bracket. And that's going to be the domain. Now notice I didn't even look at this. So this part, for that part, the domain is minus infinity to infinity, because this is just a line. But that square root is going to give us this restriction here. So I just had to worry about the square root. I didn't even really care about the x or the 15. Okay, now when I subtract f and g, I would have f, which is square root of x, minus g. Let's write this in parentheses, x minus 15, because that negative is going to distribute and make this 15 positive. So it's pretty similar. And I can use the same argument because this minus x and this 15 have no restricted values, only the square root does. The answer is just like before. We just have to make sure x is 0 or any other positive number. Now multiplication and division might be a little more interesting. So we have multiplication. F was the square root of x. G was x minus, what was it, x plus 15? X minus 15. And so we will distribute this square root of x into both of these. And we don't get very much. We get x times the square root of x, and we get minus 15 root x. So you can just put each of those terms in front of the square root x, and you've got it. And the interval is going to be the same. So we still have x bigger than or equal to 0, so we'll say 0 to infinity. Okay, now for the division, it's f over g. So we have square root of x on top, and we have x minus 15 on bottom. Now we have division, so we have to make sure that this never becomes numerator over 0. So we're going to set x minus 15 equal to 0 and solve. Well, it's pretty easy. Add 15 to both sides. When x equals 15, we're going to get divided by 0. So we're going to restrict it. We're going to say x should not equal 15. But also notice the numerator also had the restriction that x should be bigger than or equal to 0. So our interval notation is going to start at 0, including it. So it can be 0 on top, that's fine. But then we're going to go to 15 and say, okay, don't include 15. But then we can start at 15 and we can include every other positive number, 16, 17, 1,000, a million. So we go to positive infinity, and infinities always get parentheses. Okay, so that's how that one would look. A little bit interesting because you've got to consider it has to be bigger than bigger equals 0, but we're restricting that 15 because it'll make the denominator 0. Okay, 7 is more of a traditional composite function problem where you're, like I said, you're placing functions into functions. So when you have f of g of x like this, f o g and then x, this is really f of g of x. So we're putting g inside of f. And I like to think about it that way. You have an inside function and an outside function. So this g of x is inside. So what do we have? F of x is 6x and g of x is x plus 5. So what we're going to do for f of g of x is we're going to take x plus 5 and we're going to put it into the variable for f of x, which is x. So it's going to be f of x plus 5. Well, anywhere I see an x in my f of x function, I replace it with x plus 5. So notice, this x is replaced with x plus 5. And now we just have to distribute. This is going to be 6x plus 30. Okay, in the next one, it's reversing it. It's saying take f and place it into g. So we have g of f of x was 6x. So everywhere I see an x in g, anywhere I see an x in g, I'm now going to replace it with 6x. So we have 6x plus 5. And there's no simplifying to be done there, so we would just put 6x plus 5. Okay, now they're saying let x equal 2. And we can use these answers we got. So f of g is right here. It's 6x plus 30. But now we're going to replace that x with x equal to 2. So it's 6 times x, but now x is 2 plus 30. So it's 12 plus 30, or 42. Last one is going to use this answer here. And again, x equal to 2, because of this right here. So it says take 6x plus 5, but replace x with 2 again. So it's going to be 12 plus 5, which is 17. And that would be composite functions with letters, so we have equations, or with replacing x with a number. Okay, these can also be graphs. So they show us two graphs here. Y is the blue one, so it's kind of like an absolute value function or something like that, a b. And then g of x is this red line, which is just a y equals to mx plus b, some straight line. And they want us to have x equal to 5. So they've told us x is 5. And they want us to calculate g of f of x. So they want us to go to 5. They want us to go to x equal to 5 on the f curve. So we go to 5, which is right here. And then we go to the f curve, which is this red one. And we go straight across, and the answer is minus 6. So f of 5 is really minus 6. So now, f of 5 is really minus 6. So these functions are, we're giving you an x value, tell us what the y value is. So for the red curve, f, I go to x is 5, down to the red curve, and then straight over to y, and that's the answer, minus 6. Now, x is minus 6 for the g curve. So now this is an x. Let me actually write this a little differently. So now they're saying x equals minus 6, what does y equal for the, I've used the, completely botched the coloring here, for the blue curve? So we go to negative 6 in the x, which is right here. We're going up to the blue curve now, right there. Once we hit it, we go straight to the right, and we record the y value, which is 9. So y is equal to 9, and that is the final answer for this one. And I'm looking at this, and I believe I did the wrong curves. I did. So let's start this one over. It's not bad. It's not bad practice. What I actually calculated was I just found f of g of 5. What we want is g of f of 5. I went to the wrong colors. So let's start this over. So we have, let me see if I can get my colors right this time. F is blue. F is blue. So this is saying x equals 5, y equals what on the blue curve? So here's 5 again. We go straight up to the blue curve and straight over, and we get 4. It's hard to see. Y is 4. Now that's going to be the x value for the red curve. So we're going to say x is 4. What does y equal on the red curve? So x is 4 is right here, and we go straight down to the red curve and straight left, and we get the y value to be minus 5. So this answer is actually minus 5. But it doesn't hurt to practice, so we went the other way. We did f of g, they wanted g of f, and that's how you would do it. Okay, where these can get particularly tricky is when you have fractions. So this wants us to take f of g of x. So f of g of x. But what is g of x? G of x is 7 over x. So anywhere we see an x in the f curve or equation, we're going to replace it with 7 over x. So this would be 9 over, not x anymore, it's 7 over x plus the 4. Okay, now we have to, it just takes some massaging to get this part right. We want a common denominator here. So if 7 is being divided by x, we're going to make 4 divided by x, but we have to add an x up here next to it. So this is going to be 9 over 7 over x plus 4x over x. And we can see that if I add x on top and bottom, they could cancel, and I'm back to 4, so I haven't changed it really. Okay, now we can combine those denominators into 1x like that. So we have 9 over 7 plus 4x divided by x. Now when you have triple division, I'm going to show you the answer, but then I'm going to walk you through it slowly. What's going to happen is this x is going to flip up to the top. Now let me show you how that works. On the top you have 9 over 1. On the bottom you have 7 plus 4x divided by x. You can change division to multiplication if you flip the second fraction. So I can rewrite that as 9 over 1 divided by that is the same as 9 over 1 times that if I flip the fraction. Let me make this a dot so you don't get confused. So it would be 7 plus 4x. So you can change these two if you flip the fraction. Okay. Now the way you multiply fractions is straight across. So you multiply 9 times x and 1 times 7 plus 4x. So you get 9x on top and 7 plus 4x on the bottom. And we would have gotten the same thing if I just flipped this x to the top. So in a triple fraction like this, the bottom part will just flip to the top, and you'll get 9 times x over 7 plus 4x. Okay, now that's the answer, so we would write that 9x over 7 plus 4x. But we also have to look at the domain. So the first thing we have to look at is is g. So notice g of x, if we're plugging g of x into f of x, g of x cannot become undefined. Because if it becomes undefined, then I'm plugging an unknown into a function and it won't work. So we have to see, when is g of x undefined? Well, g of x is undefined when 7 over x becomes 7 over 0. And it's pretty easy to see, when will x be 0 in this case? Well, when x is 0. So we cannot allow x to be 0. If it is, g becomes undefined and you can't plug it into f of x. So that's one. And there's also another one, and that is the denominator on our final answer. So this is a numerator over denominator. We also can't let that equal 0. So we get a second one by setting 7 plus 4x equal to 0. Subtract 7 from both sides. Divide both sides by 4. So we also can't let x equal negative 7/4. If it does, then we get a divide by 0 error on the final product. So we have two restricted numbers. So let's write this answer down here. So we're going to start at minus infinity, go to minus 7/4, exclude that, pick up at minus 7/4, go to 0, exclude that, pick up at 0, and go to infinity. So all of that would be the answer for this composite function. So kind of a lot there. Okay, 10 is similar, but I think probably not quite as bad. So what we have is f of g of x again. So we're taking g, which is x plus 3, and we're putting it into f. F is the square root of x, so we're just going to replace x with x plus 3. And for this one, we just have to make sure that, so I said when you have the square root of stuff, what you do is you take that stuff inside there and make it greater than or equal to 0. Let's first write this answer. This answer is very simple. It's just square root of x plus 3. Nothing can be, you can't simplify that anymore. And then the domain is, we have to make x plus 3, whatever's inside there, greater than or equal to 0. Subtract 3 from both sides. X has to be bigger than or equal to negative 3. So as long as x is bigger than or equal to minus 3, this function will work out. Now, in the last one, I also looked to see when was g of x undefined. But notice, x plus 3 is never going to be undefined. So it's not a fraction, and it's not yet a square root. So the domain on this one is everything. So g is going to work no matter what. So the only restriction I have is on the composite function, square root of x plus 3. So we just need to make x bigger than or equal to 3, so we can start at minus 3, including it, and then we can go off into infinity. And again, used a bracket there because of this equal to sign. Okay, 11 and 12 you'll probably find to be pretty simple. We want h to be a composite function, so we want h to be f of g of x. So we just have to look at this as two things. G is the inside function, and f is the outside function. So you just have to look at these h's and decide what's inside, what's outside. So if you look at this, hopefully you'll be able to see this. This is the inside stuff. So that is going to be g. We want g to be the inside stuff, so g is 9x minus 3. The outside is what is happening to this thing. The outside is you're taking whatever is inside and you're raising it to the 4th power. So the outside part, which is f, is going to be just x to the 4th. Now let's see if this makes sense. So if I have f of 9x minus 3, but f is x to the 4th, then I replace everything. I replace f. I'm going to replace that x with 9x plus 3. Then I replace this x with 9x plus 3. I'm going to get f of g of x is equal to the inside stuff, 9x plus 3. And then what am I doing to it? We're raising it to the fourth. So all you need is x to the fourth there. And then once that x is replaced with this inside stuff, it will become exactly 9x minus 3 to the fourth. So just to be clear here, let me delete some of this. Your final answers would be f is x to the fourth, and g is 9x minus 3. Last one in section 2.6 is the same kind of thing. So hopefully it's not too hard to see that the inside part, which is g, is x squared minus 9. And the outside stuff is whatever is happening to that inside, which is the root, is the 8th root of that. So the outside is the 8th root of, and you just need a placeholder, so it would be x, because we're replacing that x with x squared minus 9. So if that's the inside and outside, it would form that h right there. Section 2.6.